Right, good day colleagues, good day grade 10s. My surname is Mpahama. I'm still continuing with the functions. Remember, a week before last week we did linear functions. So today we're going to look at the quadratic functions. But before we start with the quadratic, I just want to recap on what we did last time when I was here. I did indicate that when we are dealing with the functions, there are three main questions that we must be able to do at the end of this topic. Number one is we must be able to sketch all these functions that I've mentioned earlier on. And then number two, you must be able to determine the equation of each of them. And the last one then will be the part of the interpretation. Please keep it in the mind that this is the objective. At the end of these sessions, make it a point that you are able to sketch, you are able to determine the equation, and also you are able to interpret if the sketch and the equations are given. Right. Then let's start with the quadratic function. Yes. Quadratic functions, if you don't want to say quadratic functions, then you can call it a parabola. No, it's the same thing. Right now, let's look. Now we are in grade 10. Remember, we are in grade 10. Then the quadratic have the formula. Quadratic have the formula. The quadratic function have the formula y is equals to ax squared plus q. Very, very important. Keep that in mind. If I can just recap, for linear function, we said we have y is equals to ax plus q for the linear, but now we are dealing with the quadratic. It's y is equals to ax squared plus q. Yes, I need to start here, and please make it a point that you look at the investigation at your own time, at your own pace, and then you sketch it, because here I don't have enough time to take you through, to give you time to sketch it. What is important is I just want us to observe what is it that you're going to get at the end of the day. Right, the first investigation that you can do at your own pace is to complete the table and then draw the graph of each function on the same set of axes. Very important. This is a table. It means what you need to do is to sketch the graph of x squared. You complete the table and then you sketch graph, and then you have 2x squared and then you have 3x squared. Right, that is the most important part. Then from there, when you look at this one, if x is 2, then you substitute it in here. Minus 2 squared will be 4. Then if it's a minus 1, then you substitute it in here. Minus 1 squared. Remember, I must indicate that every time when you substitute something, then put it in the brackets, because in our calculator, if I just say minus 1 squared, it says it's minus 1, which is not true, because you understand from the exponent, if I've got minus 1 all squared, it says I must multiply negative 1 2 times. So the answer won't be negative, it must be positive. Then please remember to put it in the brackets, even if you put it in the calculator. Right, the 0, then it will be 0, the 1 is still 1, the 2 is still 4. 2 squared is a 4. Then you do the same thing with a 8, you do the same thing, 2x squared, you do the same with 3x squared. Let us look at the function. How does it look like? Here it is. Look at the first one. This is f at x, or is equals to x squared. The first one you started with. Look at the second one, f at x is equals to 2x squared. And look at the third one, f at x is equals to 3x squared. That is why I said give yourself time, complete the table, and then have a feeling of drawing the three graphs. Sit down and then draw them. And then after that, let's observe what is happening. Let's observe what is happening. Look at f at x is equals to x squared. The coefficient, the a here, is a positive 1. The second one, a is 2. Remember, we have f at x, or y is equals to ax squared plus q. At the moment, q is 0, then but a is 2. Look at the graph. And then here, a3. Look at the graph. Maybe to make more sense, let us do it in this way. Let us do it in this way to make more sense. Let us look. Maybe we can have the three of these functions here. The first function that we have, we started first with x squared, right? We started first with x squared, and let's see what is happening. Then, yes, let's see what is happening. Then I can leave that red color there. It's fine. Then we have the function. Here it is. Look at what is happening with this graph. Yes. Now, I want you to do the observation. The second graph now that we're going to draw will be now what? 2. It is 2x squared. Then it is 2x squared. Let me make it yellow. I hope it will be clear. Right, there it is. And then the other one, then let me make it 5. Nay, let me make it 5x. 5x squared. Then I can make this one blue. Can make this one blue. Where are you, blue? Okay, let me take navy. No, navy, not clear. I'm looking for the blue. There is blue. Yes, let me make it blue. Thank you. There we are. Right. We have x squared, a is 1. We have 2x squared, a is 2. We have 5x squared, a is 5. Look at observation. The last graph that I'm going to draw now is where we have 0, 5. You know 0, 5 is half, nay? Yes, 0, 5 x squared, 0, 5, which is a half, nay? I can also make it blue, no problem. Look where it is. Now, can I conclude to say, look, if a is 0, 5, the graph moved far away from the y-axis. But the other one, the 1, the 2, the 5, they are moving closer to the what? They are moving closer to the y-axis. Very important. It means that the value of a talks to the stretch, the vertical stretch of the the graph. Please keep that in mind. Then it means if a is bigger, the graph gets closer to the y-axis. But if a is smaller, then the graph move away from the y-axis. Keep that in mind. Very, very important. Okay, right. And then from there, this is observation that we have seen. Let's move to the next one. Right, the second investigation. It says complete the following table and then you draw the graph of each function on the same set of x's provided. Right, in this case now we have now -2, -1, 0, 1, 2. That is most of the time what we encourage to say. If we are using the table, the minimum that you can have is to have 2 values on the left hand side of 0 and 2 values on the right hand side of the 0. That is the minimum that you can have. But you can have more than 2. Right, from there, you can have x squared, you can have x squared minus 2, you can have x squared plus 3. Then you complete the table. After completing the table, then what you expected to do is that you now draw the function of each of these. Very, very important. Right, let's see what is it that we are having. Right, these are the graph. Can you tell exactly what is happening? Can you tell? This is f at x squared, here it is. Nay, it's at origin there. The turning point, I'm going to talk about the turning point, it's a 0 and 0 here. The turning point is 0 and 0. But the one of x plus 2, the second one, here it is. Now, the graph turns at 2. What happened? I can shortly say now the graph moved 2 units up. I can say the graph moved 2 units up. Very, very important. Please make sure that you look at it. Now, the third one says f at x is equals to x squared minus 2. Then the graph is going to do what? Yes, I can hear some of you guys are saying the graph has moved 2 units downwards. Yes. Then what do you observe here? The 2 is a q. Here, q is 0. That is why the graph turns at origin, where x is 0 and y is 0. But the second one, q is equals to 2. The value of q is equals to 2. Look what happened. Now the graph will turn where x is 0 and y is 2. And the third one then, x squared minus 2. The value of q is a minus 2. Then if that is the case, look what happened to the graph. Then the values of the turning point x there is a 0 and then y is a minus 2. So in short, q then shift the graph up if it's positive. And then if it's negative, then the graph will shift downwards. It will depend on what is the value of what? What is the value of q? Very, very important. Then I mentioned something as well. I mentioned something on the turning point where the graph turns. Then I can also say now the same q will be the y value at the turning point. The q will be the y value at the turning point. Right, we have an idea now. We have an idea of what is happening here. And then let me just see. I think we have seen what is happening. We have seen what is happening. Let me have now see more on the vertical shift. On the vertical shift is not that difficult. Let us see more now on the vertical shift, so that at least we are very clear on what is it that can expect from us, especially now where we are trying to build the foundation for grade 11 as well as grade 12. Right, thank you. Now, the first graph, we call it the mother graph. Name, it's x squared. Here it is. That is where we start. Right, what did I say? I say the graph will turn at 0, x0, and then y0. That is the mother graph. Then the first one you have seen. What is it that you have seen? You have seen that we have x squared. We have x squared plus 2. We have x squared plus 2. Then what's going to happen here? X squared plus 2. Then the graph shift 2 units up. 1, 2. Look, the x was 0, the y 0. But now here what is happening? X is 0, then y is what? Y is 2. The graph moved 2 units up. And then let me have the last one. And the last one then will be where we have x, exponent 2, then we have minus 4. If you have that, then the graph will do what? Yes, you are 100% correct. The graph will move 4 units downwards. Then what does this one tell us? Q is a positive 2 here, Q is a 0 here, and then Q is a minus 4 here. Please, grade 10, keep this in mind because that is where you start now the function. You shift now the graph vertically. Up, the Q will be positive. Down, then the Q will be negative. Very, very important. Let's keep that in mind. Right. In conclusion, now we can say now the value of A in the equation y is equals to ax squared plus q. Let now forget about the negative now, because I can have minus 2, I can have positive 3. Let's ignore the negative now. Determines the closeness of the arm of parabola to the y-axis. Remember I said that the larger the value of A, the closer the arms are to the y-axis. It means now the graph moved closer now to the y-axis. But now if there is a negative in front of the coefficient of x squared, if there is a negative in front of the coefficient of x squared, then that negative will cause a reflection in the x-axis. Now we'll talk about the shape. Now you will see. Now if the graph was facing up, the arm was facing up, then if you put the negative, then the arm then will face down. What does that mean? If A is greater than 0, hey, grade 10s, greater than 0 says then values are positive. We am referring to the 1, I'm referring to the 2, I'm referring to the 3. Then those values are greater than 0. Then the quadratic function of the parabola is concave up. We say it's a happy face. I don't know if you can see that when you are happy, what is happening on your face. Please just practice. Go to the mirror and then you try to practice that. Very important. But now, the quadratic functions, it face up. It's face up, that is why we get concave up. Then if A is less than 0, I think all of us here, we know when you talk of the less, what is it that we are referring to? Yes, I can see most of you are referring to the values that are negative. Very important. If the coefficient of x squared is a negative 3, negative 5, negative 10, then the graph then will face down. Then we say parabola is concave down, or we can say set face. Yeah, this one as well, just practice this as well. Go in front of the mirror and get angry and then see how you look at the face. Then you will understand when we say happy face and when we say the set face, what is happening to this quadratic function. Right, the last part now, like I indicated, the value of A is sometimes referred to as a vertical stretch factor. Please keep that in mind. Right, now, the last investigation that you did was on the Q. Now, the value of Q in the equation y is equals to ax squared plus q determines the shift of the graph. I said that. The value of Q in the equation y is equals to ax squared plus q determines the shift of the graph of y is equals to ax squared. Up or down. Up or down. Now you know very well, you will see when the graph goes up. You also know when will the graph go down. If P is positive, if Q is positive, not P. If Q is positive, then the graph go up. It's x squared plus 5. The graph will go 5 units up. If x squared minus 2, then the graph will go 2 units downwards. Keep that in mind. It also represented the y-intercept of the graph of y equals to ax squared plus q. Hey, when you talk to the y-intercept, that is where the graph will touch the y-axis, will pass the y-axis. Very, very important. So there's one that you want to add as well, not only the y-intercept, but one thing that you've also learned based on the investigation that you did is that q as well is what? Yes, I can get it very well that you are saying the q is the y value at a turning point. Very correct. The q is a y value at a turning point of that quadratic function. Please keep it in mind. What is the effect of A on the graph? If it's positive, if it becomes negative, then it will be the reflection, right? And then from there, what is the effect of Q on the graph? Q positive, the graph go up. Q negative, then the graph will go down. Also, Q represents the y-intercept as well as the y value at a turning point. Right. Let's take notes. Fine. We have a quadratic function or quadratic equation. Now, let me put a quadratic function. Y is equals to ax squared plus q. This is what we know. That is a quadratic equation. Okay. Y is equals to ax squared plus q. Very important. One thing, once you see x squared, we are talking to the quadratic, then what comes in your mind is the shape of the graph. The shape of the graph. I said to you, if a greater than 0, then you have a happy face. No, it means a is positive. You have a happy face. Your graph, the arms will open up, right? Then that is why we say concave up. Then if a is less than 0, guys, you remember very well when you talk of negative numbers. Nay, we say they are less than 0. Then the graph is negative, then it will face down. Keep that in mind. Ax squared, you look at the coefficient of a, coefficient of x squared. If it's positive, the graph is happy face, concave up. If it's negative, then the graph is concave down. Keep that in mind. Then we also indicated that Q equals to the y-intercept. Q equals to the y-intercept. Very, very important. Q is a y-intercept. Then I also indicated that based on the investigation, then the turning point on the graph, this Q is a y value at a turning point. But on this graph, to be specific, remember on the linear functions I indicated something that is so important today is that what must happen? We have m, and m represented a gradient. It's either it's m or it's a. In the linear, that represented a gradient. But here now, that one does not have a turning point. This one does not have a gradient. We have a turning point. We have a turning point. That is where the graph turns. In this case, the graph turns at this point here. We need to know what are the coordinates of this point. And at this time, the graph make a turn here. Very, very important. Now, you must be able to determine the coordinates of the turning point. But one thing that you have learned from the investigation is that Q is always be the y value at a turning point. Q will always be the y value at a turning point. Right. Now, the other thing here, we have the domain here. Now, I decided to disappear here, but we'll talk about it. It's all x values. Remember, when I talk to the domain, we talk to the values of x that form part of the graph. Now, if you draw the sketch, and then after drawing the graph, then you take the ruler and then you put it vertical, like, vertically like the y. When you draw the y-axis, now you move from the left to the right. Now, immediately, once you start touching the graph, that is where your domain starts. If you start touching your graph at -2, then your domain starts at -2. Those are the x values that form part of the graph. Then you move up until you get to the last one. So what I'm saying is, when you determine the domain of the graph, you start from the lowest value. We read from the left, we go to the right. Very, very important. Then you move with the line up until you get to the end of the graph. Then the domain then will also end there. Keep it in mind. Now, how do we write it? Yes, I don't know what happened to it here. How do we write it? Then we can say domain is x element of what? element of real numbers. Yes, that is how we represent the domain. What is the meaning of this one? Is all values of x, right? It's all values of x. Then the other one that I can also say, if I don't want to say this one, I can also say the domain then will be what? X is an element. Then when you talk to all the values, where do they start? They start from the negative infinity. Where do they end? They end to the positive infinity. That is another way of representing the domain. It's either you say x element of real, or you say x element from negative infinity to positive infinity. Keep that in mind. Right, now we are fine with the domain. Then the range. When you look at the range, we have y element p, supposed to be q, not p. Q is an element from q to positive infinity. That is a minimum if a is greater than 0. Please, that is q. Yes, that is q. Okay. I wanted to see if I can correct it, but not a problem. Please, that is not p, it's a q. I will write it here. The first one, we have y element, right? Because we say the graph A is greater than 0, then it will face up like this one. Now, how do I look for the range? Now, I said for the domain, we move vertically from the left to the right. But what about the range? Range, then I will move horizontal. Then it means I will move from here. Immediately when I start touching the graph, that is where the range then will start. Then I go up. Where I stop touching the graph, then the range then will end there. So in this case, we are going to start here. Then since the range are the values of y that form part of the graph, then we will say we have the q here. Remember, it's a 0 and q. 0 and q, which is a turning point. Then it means you're going to start from q, then to positive infinity. This value here is a minimum. Right now, the question then will then be, the q, is it a part? Yes, it is the part of the graph. So that is where we're going to use the square bracket. Right now, why here the round bracket? Because you know what is a negative infinity? We don't know. So it's a round bracket, but when we come this one, because you know q is a part of the graph, that is where now we will use the square bracket. Okay, then if you don't want to do that, we can just say y element of real, then y is greater or equals to q. Please remember that. Right, the second one then will be, this one applies where a is greater than 0. This one applies where a is greater than 0. Then we will have happy face, right? Yeah, we're going to have a happy face. But in a case where a is less than 0, what's going to happen? Then we're going to have a graph like this one, facing down. Now, how do we write the range? Then we say y is in an element. Then we start from the lowest. Remember, how do you look at the range? You place your ruler horizontally, then you move. Where you start touching the graph, you start from down. You start from down, from the negative side. Where you start touching the graph, then that is where the range starts. Here, start from the negative infinity up to where? Up to where the graph ends. What are the coordinates of that? It's y and 0 and q. Then it means you're going to have q there. Negative infinity, round brackets. The q then is a square bracket. Say it is a part of the solution. Right. The other way, then you can say y element of real, then y less or equals to what? Y less or equals to q. Please, that is the range of the quadratic functions. Keep it in mind. Yes. Please make note, this is not p, it's a q. That is why I did it on that. Focus on what? Focus on what is written on the other side. Thank you. Then we have axis of symmetry. X is equals to 0. Right. Now, what is it that you are referring to here? When you look at a graph, maybe let me start it on this side first. When you look at a graph, let me go to the graph. This is the graph, right? axis of symmetry, it's this line here. It's this line here. Maybe I must do this one. Maybe I must do this one so that we can see what you're talking about. Right. Axis of symmetry is this line here. This line cuts this graph into two equal parts. I can have another one here so that it can make more sense to you now. So let me have x squared minus 4. Let me have x squared minus 4. Let me have x squared minus 4, x squared minus 4. Then this is x squared minus 4. Right. Now, look, this line cuts the graph into two equal parts is a image of the other one. Right. Now, why am I saying that? This is 0 here. Look at the distance from here to that side. It's a 2. 1, 2. And also look at the distance from this to that. It's also 2, 1, 2. So can you see now? It divides this graph into two equal parts. So what is the equation of that? We look at the x value at the turning point. That is why on the other side we said x is equals to 0. Then at the turning point, what is the x here? X is 0. And then the y is q. So you take the x when you determine the axis of symmetry. Right. Okay, please keep that in mind. Keep that in mind. Thank you. Right, now, please make sure that you understand these notes. We are going to do now some examples so that at least we know what is it that is expected from us. The first part that we must do is to sketch the graph. The first thing that we need to do is to sketch the graph. We are given f at x is equals to x squared minus 4. Right, we are given that f at x is equals to x squared minus 4. Right, the question then is to sketch the graph. We must sketch this graph. Right, okay. Now the first question that we have is write down the coordinates of the y-intercept. You know, when you talk of the coordinates, you must be having at that point you have x as well as what? X as well as y. And you also remember that in the linear functions, we did sketch the graph using the table and also using the dual intercept method. Very, very important to recall on what you did in the previous grade or in the early topics. Right now, when they say we write down the coordinates of the y-intercept, what do you remember about the y-intercept? Yes, I can see some of you guys are saying, yes, when I determine the y-intercept, I must let x to be 0. You are very correct. You are very, very correct. You must let x to be 0. So you have y is equals to x squared minus 4. That's what we are having. And then from here, what's going to happen? Then you let x to be 0. Then you have 0 squared minus 4. Therefore, you have minus 4 there. Therefore, the value of y it's a minus 4. Keep it in mind. The graph will pass the y at minus 4. Good. Therefore, the set must write the coordinates. Therefore, at that point, x is 0, and then y is minus 4. Do we have it? Yes, I can see the smile. Nay, you are very, very correct. X 0, y minus 4. The second one is determine the coordinates of the x-intercepts. Determine the coordinates of the x-intercept. What do you remember from the previous work that we did, especially on the linear? Yes, for the x-intercept, we said we let y to be 0. So what do you do now? We let y to be 0. So it means in this case, we are going to have what? We are going to have now y is equals to x squared minus 4. Then we let this one to be 0. So 0 is equals to x squared minus 4. Right, what do you see now? Yes, some of you are smiling because you are recalling now that earlier on you did the equations and inequalities. Now, under the equations, when you had two terms, what were you thinking of? Yes, when you factorize this one, then you will take out a common factor. If there is a common factor, that is where we always start. But if there is no common factor, when we have two terms, then one thing that comes into our mind is the difference of two squares or sum and difference of two cubes. But at the moment, it's x squared, and then it means it's the difference of two squares because of the minus. Now, how do you factorize that? You would have your two brackets, then you look for the factors of x squared. It's x times x, and then factors of 4 is 2 times 2. Why do I take 2 times 2? Because when I take 2 times 2, when I minus the 2, then the answer is 0. So it means one is positive and the other one is negative. Therefore, now I can have x plus 2 is equals to 0, or I have x minus 2 is equals to that what you did earlier on, ne? Yes, and therefore x is equals to minus 2, or x is equals to positive 2. Then what are the coordinates? Then here x is minus 2 and 0, and also x is 2 as well as what? 0. Y will always be 0 because y will always be 0 because you said for the x-intercept you must let y to be 0. Let's see if we are right. There we are. I've already done that. Then you factorize it. Remember f at x, g at x, w x, those ones represent the y value. Nay, represent the y. Okay, then you have it here. You have x is equals to minus 2, or x is equals to that. Therefore, the x-intercept, we put minus 2, 0, 2 as well as 0. Now we need now to sketch the graph. Can we do that? Can you do that? No, I can see now you don't remember. Fine. When you do that, you remember what you must do, right? And please make use of your ruler. You know the free hands does not help. Especially when you draw your x-axis as well as your y-axis. Make use of a ruler to make sure that your graph looks nice. So you draw that line. This will be your y-axis. Then you indicate it there. You indicate this is my y-axis. Please, very important, you see what I'm doing. I'm trying to make sure that the distance between each point is the same. Then from there, I must now draw the y. This is the y-axis. Now I must draw the x-axis now. So you do the same thing. This one. There you are. Okay. Then I can now name this one to say this is an x. This one is a y. Thank you. Right now, this is 1. This is 2. This is 3. 4, 5, 6. Minus 1. Minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. So this is 1, 2, 3, 4, 5, 6. That is 6 there. Okay. Now, let's go back and see. I will use this one here. What is a y? We said y-intercept, the coordinates of the y-intercept is a 0 and minus 4, right? We indicate that. 0 minus 4. Here it is. 0 minus 4. X 0, y minus 4. Then after that, you go for the x-intercept. The x-intercept we have, for x-intercept, we have x minus 2 and 0. We show that. This is x minus 2 and 0. Then we also show what? 2 and 0. Then here's 2 and 0. Then the 3 points, now I can sketch the graph. Then the graph then looks like blah, blah. Then here we are. Then there's a turning point there. Then the graph then go up. Here we are. That is a quadratic. That is a graph of F. Please, your turning point, this is not a turning point. Please, let the graph Fs move curve on that at the minus 4. Where y is a minus 4, and then x is 0. Right. Let's now look at that. Please just compare it with what we are having. Here we have this one looks exactly as the one that I have drawn on the other side. Right. Okay. Right now, from the very same graph, then what are the coordinates of the turning point? What are the coordinates of the turning point? Yes. Remember what I said earlier on, Q will always be the y-intercept, the y value at the turning point. So the Q here is what? It's a minus 4. Then let's see what is x. X is 0. Nay, because just the graph, at first the mother graph x squared, the coordinates of the turning point x0, y0. Now when you say minus 4, then the graph moves 4 units down. But the x stays the same. The only person who's going to change here is y. Then it will become minus 4. Then that is why it is 0 and minus 4. Okay. Then the next question is determine the minimum value of the graph. Then earlier on I indicated that when a is greater than 0, we would have the minimum value. And when a is less than 0, we're going to have the maximum value. So in this case, we have the minimum value. Why? Because now the value of a in front of x squared is positive. Therefore, the minimum value is equals to minus 4. But if it was a set face, or concave down, then we will have the maximum value. Please keep that in mind. Right, they ask us to determine the domain of the graph. Yes, domain of the graph, values of x that form part of the graph. Very important. Then it means you're going to have x element of real. If I don't want to say x of element of real, can you remind me what must I say? Yes, x element, the graph starts from negative infinity. It will end at a positive infinity. Let's keep that in mind. What about the range? What about the range? Values of y that form part of the graph. How do I read? I go horizontally from the negative up, from the lower up. So it means now I'm going to start at the minus 4, x element minus 4 square bracket, right? Square brackets minus 4 to positive infinity round brackets. Or I can say y element of real, y greater than minus 4. These are the answers there. This is supposed to be y element of real. No, supposed to be y element of real. That is that grade 10. Please make sure that you master this part. Okay. Right now, we have now, when you're reflecting the straight line and the parabola, remember I mentioned the value of a being reflection and what. Now we're given now y is equals to 2x minus 4. But let me start on the one that we're busy with. That when you talk of the reflection, then we are changing the y values. The only person who's going to change it is a y. So that is why we put the y negative there. So we have y is equals to x squared. Now we are going to have negative y is equals to x squared. Then what do we do after? We're going to divide each term by the negative. Therefore, we have y is equals to negative 2x squared. Then the graph was a happy face. Now it's a minus going to be sad face. Now we reflected it on the x-axis. Who's going to change there? Y. Y must be negative. Right? If it was negative, then y will be positive. The same applies with the linear. Right? You do the same. Minus y is equals to 2x. 2x minus 4. Then from there, since I'm reflecting this on the x-axis, then y is equals to, then this is minus 2x plus 4. Y plus negative divided by negative, then it's a positive. Right, number 2, reflect in the y-axis. Now, if we reflect it on the y-axis, now the values of x are the one that are going to change here. The values of x are the one that are going to change here. So this one, the linear one, we replace x with a negative x. We replace x with negative x, then this will then be between 2 minus x minus 4, then y is equals to minus 2x minus 4. Right, this one, the brackets was supposed to be negative x all squared. Now decided it's supposed to be y is equals to, let me write it down so that you can see. It's supposed to be, we have y squared is equals to 2x squared, right? Now what? So not y squared. Y is equals to 2x squared. So what must happen is y is equals to 2. We replace x with negative x squared. So this will still remain the same. It will still be 2x squared. Why 2x squared? Yes, I can see now. Some of you are saying when you take negative x times negative x will give you positive x squared. Right. Okay, now the grade 9, you remember, you reflected the graph on the line y is equals to x. What did you do there? You swapped the values. X, you swapped x and y around. So in this case, x is equals to 2y minus 4, and then after that you make y the subject of the formula. You kick on the other side, then it will be minus 2y is equals to minus x, then minus 4. Then from there you divide by minus 2, then it's a half x plus 2y plus 2, because negative divided by negative is it's a positive. Right, this side, it's x, you replace x by y, so x is equals to 2y squared, then divided by 2, then make y the subject of the formula. Since this is a y squared, then you can now square, you can now apply the square root on both sides. Yes, remember we have reflection about it there, x-axis, y becomes negative, we have reflection about it there, y-axis, it's x who's negative now. Reflection about the line y is equals to x, you swap the values around. Yes, something that I almost forgot, especially when you determine the x-intercept. Yes, one of you reminded me that we have y is equals to x squared minus 4, then this must be 0 is equals to x squared minus 4, and then you can take 4 on the other side, it's going to be positive 4 is equals to x squared. And then they are saying that on this one, you can just apply the square root on both sides. Then the square root of x squared is x. Then the other side, the square root of 4 is what? is 2. Then I said to them, yes, I can use this one, but the mistake, why am I not using this one? We forget to write plus or minus here. It must be x is equals to plus or minus 2. So if you are using this one, please remember to write plus or minus 2. Yes, thank you for the one who reminded me about this one. So you guys, you must also do the same. Don't forget that. I almost forgot to mention it. Okay, now we can take example. I think we are ready. The exercise given that the function f at x is equals to 2x squared minus 6 and g at x is equals to minus 2x plus 6. Yes, I've got 2 already. They want us to draw f and g on the same set of x's and then calculate the point of intersection of f and g, then use the graph. Okay, this is a very nice exercise. Please look at it. I want you to go through it. Once we finish the functions now, I'm remained with 2. Then we're going to discuss this one. We need to talk about, especially from 1.3, 1.3.1 to 1.3.2. That is the one that I want. I want to see what is it that you're going to do here. Please grade 10. Just engage on it. You can discuss it with your friends. Then after that, then I will come and give the solution for it. Okay, right. Please copy the question. Look at it, copy it, and then this one, it is your activity now. You must do it. Yes, you must do it. You know, we are not watching the movie, right? Yes, you must do it. Yes, good. We'll give the solution. I think we have seen all the questions. Yes. Let me continue, then we'll come back to it. Yeah, let me continue, then we'll come back to it. Okay. Right now, this was the part where we sketch the graph. Now, very important, this is the part where we sketch. It means that is our first objective. I need to know how to sketch the quadratic function. If I know that, it's a tick on my side because that is a skill that I need to know. Right, the next one then will be, we need to know how to find the equation of a quadratic function. Remember the objective, know how to sketch, and the second one, know how to determine the equation. Now, what do we do when we determine the equation of a quadratic function? I remember very well on the linear, we said for us to determine the equation of the linear function in the form y is equals to mx plus c or y is equals to ax plus q, then we said we needed a gradient, right? We said we needed a gradient. Nay. Right, then the other question was, how do I determine the gradient? For me to have the gradient, I need to have 2 points. Yes, I need to have 2 points. But there are situations where I have only 1 point. Then what do I do in that case? Then we reminded each other to say, if you have 1 point, you look for the word parallel. Then also look for the word perpendicular. Then to say when lines are parallel, then it means they will have the same gradient. And also when lines are perpendicular, then the product of the gradients will be -1. It means m1 multiplied by m2 will give us the -1. Right, now, that is that, and then we substitute 1 point on that. If there are 2 points, we just take 1. Right, but now we are here. We are finding the equation of a quadratic function. What do we need here? Very important. We need to have the value of q. If you can see a q, then we are happy. The second one, we need a point on the graph. The value of q and a point on the graph. Right, okay. Let's see now. We have now f at x is equals to ax squared plus q. Determine the equation of the graph below in the form f at x is equals to ax squared plus q. There is a graph. What information do you see from the graph? I see the y-intercept there is a 3. Then I also see a point on the graph, x is 2, y is 2. Very important. Okay, let me look at that. This is what we are having. This is 3, the point is 2, and 7. Okay, they say we must determine the equation in the form y is equals to ax squared plus q. Then you still remember, what is a q? We said q is a y-intercept, right? So it means in this case, q is equals to 3. Then I can substitute it. Then I can now say y is equals to ax squared plus 3. Good. Then what is the problem now? Yes, I can see you guys are talking. Yes, there is a problem. Problem is the value of A. Problem is the value of A. Don't be afraid. You must tell me, say, we need to determine the value of A. Yes. Let's now find the value of A. How do we determine the value of A? Any idea? You remember what we did on the linear function, right? Yes. We took a point on the graph, then we substituted. Then you are 100% correct. Then it means you're going to take one point here, which is 2, and x is 2 at that point, and y is 7. Then you're going to substitute the point. Then what is y? Then y is 7 is equals to A. What is x? X is 2 squared. Then plus 3. I substituted. Now I'm happy now. I substituted. Now I'm going to solve for A, right? Yes. Now we move 3 on the other side. We minus it on both sides. So 7 minus 3 will be what? Will be 4. 7 minus 3 is 4. What happened? No, say we don't see. Okay, it's a 7 minus 3 is equals to, then this is on the other side. We minus 3 on both sides. Then we have 2 squared. What is 2 squared? Is 4. Then 4 times A is a 4A. Happy about that? Yes. So what is 7 minus 3? Is 4 equals to 4A. Then divide by 4, divide by 4. Therefore, A is equals to what? A is equals to 1. There we are. Right now, I know what is Q. Now I know what is A. Then I can now substitute it back now, because the question was to write the equation in the form AX squared. They said I must write the equation AX squared plus Q. That's what they said I must do. So what is A? A is 1. Then I write it. I don't write it, still 1 there. The coefficient is 1. Then plus 3. That is the equation. Keep it in mind. What happened? First, I checked if there is a Q. Then there is a Q is 3 from the graph. That is a y-intercept. And then after that, I look for the A. What did I do? I substituted a point from the graph. So that is why now I got A is equals to 1. Then from there, I can substitute back to the graph, to the equation. Okay, are we fine? Please make sure that you practice this one. It's very, very important. Then the next one here, we are having another example. They say determine the equation of the graph below in the form. Look now, what is it that we are having now? Can you see what we are having? We are having now minus 2, minus 2. This minus 2, minus 2 are the x-intercept of the graph. That is where the graph touches the x-axis. Good. And you remember, when it was like this one, we had 2 brackets. Nee? Yes, we had 2 brackets. Now, what must we do now? The graph looks like this one. It's a minus 2, positive 2, and we have a point there, 1, 6. Right? This is y, this is x. Right, what must we do? First, we have y is equals to ax squared plus q. Then we need to determine, do we have q here? No, we don't have q. Then it means we don't have a, we don't have q. So what do we do? Right, the first thing that we can do here is to remember that we have y is equals to a into x minus x1, x minus x2. We are given the x-intercept, so we can use them. We are given the x-intercept. So I can just substitute in x minus x1 is this one. So it will be minus 2. Then we have x minus 2. There we are. Then we have a. X negative negative is a positive. Then we have x minus 2. Good. Then before I multiply the brackets, then what can I do now? I still don't have a. Now what is it that I need to do? Then I look for the point on the graph. There is a point. Then I substitute that point. x1, y6. Then after that, then y will be 6 is equals to a into 1 plus 2. And then we also have what? We also have 1 minus 2. So I can simplify this 1 plus 2. Then is equals to 3. And then 1 minus 2 is equals to minus 1. So 3 times that will be negative 3a is equals to 6 is equals to 6. Then what do I do? Then I divide by minus 3, divide by minus 3. Therefore, a is equals to negative what? Negative 2. Then I have that. Then from there, what can I do now? I can then substitute it back. Therefore, y is equals to a is a minus 2 x squared. Then multiply first. Okay, let's multiply first. Yes. I can see one says here, but we need to multiply first. Yes, you are right. So let me write it on this side. So it's going to be y is equals to minus 2 outside. Then you're going to take it from here now. From here, we come here. So minus 2 into, so it's x plus 2 minus 2. Then when I multiply out, it's a minus 2 into x by x is what? X squared. X by that is a minus 2x. This will be plus 2x, then minus 4. Good. Then it's equals to minus 2 into x squared. These two cancel each other. Then you're going to have minus 4. Then I multiply the 2 out. Now it's a minus 2x squared. And then plus 8. There we are. That is where I was getting earlier on. So please remember, you can use those x-intercepts to do what? To determine the equation. Very, very important. Then the other one then can be the simultaneous one. Then please try it now. When now you substitute the point, then after that you take one of the point now. Then after that you solve them simultaneously. Very, very important. Okay, but then, okay, practice this one as well. Practice this one as well. Right, that was the second example on determining the equation. Right, this was one of the papers that you guys, other grade 10 learners wrote. The graph of f at x is equals to x squared plus q is given below. Point A and B lies on the graph of f, very important. Point A and C are the x-intercept of f. There we are. Right, the first question here is 4.1. Write down the coordinates of C. Write down the coordinates of C. What is C? C is the x-intercept. Now, how do I get to this point here? Yes. I can see one of you is saying that since we have axis of symmetry, and then we said this one divides the graph into two equal parts, then it means the distance from the origin here to A is the same as the distance from the origin there to C. So if this is 2, then this one will be 2 as well. So then if it's a 2, but x on this side there, they're negative. So it means now 4.1 there, we have C. We have C as a point, what? As a point minus 2 as well as what? C as a point minus 2 as well as 0. Please keep that in mind. Right. The next one says determine the equation of f. Determine the equation of f, more or less similar to the one that we did earlier on. Can I leave this one for you? No, say you must do it. Okay, let me quickly look at it. Now, what do we have? We have, that is 4.2. We have y is equals to ax squared plus q, right? And then from the graph, we are given now, I will switch between the two. From the graph now, we have the x-intercept. It's x minus x1, and then x minus x2. Then it's equals to y. Then from there, we have a into x minus 2, and then we have x plus 2. You understand why plus? No, it was minus 2. When you multiply the 2, they become positive. Then from there, we have one point on the graph. Look at that point. The point I'm referring to here is this point here. Is this point right now. We're going to substitute the point B, where x is a minus 3, y is 2,5. No, let us substitute the point. Then we have 2.5 is equals to a into minus 3 minus 2. Then we've got x plus 2. Minus what? Minus 3 plus 2. So when I simplify this one, I get a into minus 5, and this will be negative 1. So negative times negative is a positive. Therefore, we have got 5a equals to 2,5. Then we divide by 5, divide by 5. Then what do we get? Let's divide by 5 and see what we are getting. We have 2,5. 2,5 divide by 5. Then the answer is half. So it means now a is equals to what? A is equals to a half. Right. If that is the case, then you know substitute it back. You see now y is equals to 1 over 2. You multiply out this bracket here. Now, you still remember the answer. It will be x squared minus 4. Yes. x squared minus 4. Good. Then from there, you times a 1 over 2x squared, and then minus what? Minus 2. That is the equation. That is the equation. Please remember the equation. Okay. Right. And then from there, they say write down the range. Write down the range of f. What is the range? Values of y that form part of the graph. Yes, one just want to give the answer. You are seeing now the answer is what? Y element, square bracket, yes, minus 2 to positive infinity. Yes. One says, say, the answer there is y element, square bracket, negative 2 to positive infinity. You are 100% correct. Or one can say y element of real, y is greater or equals to minus 2. Please keep it in mind and make sure that you practice how to do it. Okay, write down the range of h where h at x is equals to, what is this one here? Y negative is a reflection about the x-axis, minus 2, the graph move 2 units downwards, right? So it means what's going to happen? What's going to happen? Let's quickly look at it. Let's quickly look at it and see what's going to happen. We have the new function now is h at x is equals to minus f at x minus 2. So what do you do now? You are reflecting this one on the x-axis. So it will be minus into a half x minus 2, then minus 2, right? You multiply the y with negative. So then we have negative 1 over 2x, then plus 2 minus 2, then we get negative 1 over 2x. Now it becomes a set face. Now what is a range? Range then will be y element from negative infinity to 0, because now it is at origin. Now the graph now looks like this one now. The turning point x is 0, y is 0, because the value of q there is equals to 0. Right, that is the first one. The first example, here it is. I'm going to leave this one for you to do. Very important. Write down the range of g. Obviously, that one is given. They say the turning point or the y-intercept, there it is. Then from there, determine the value of a and q. Then if r is minus 2, use the graph to determine the values of x for which f at x is less than g at x. Okay, right. Grade 10, I said we also need to know how to interpret. Look at this example here. In the diagram, the graph of f at x is equals to 4 minus x squared, and g at x is equals to x squared plus 6, and h at x is equals to 3x squared are shown. How many graphs do I have? I have 3 graphs. Yes, I'm just going to talk about it, and at your own time, please make sure that you respond, you do it. Now, the graph of f cuts the x-axis at a. Cuts the x-axis at a. What is this one here? It's a y-intercept. Note that you immediately indicate this is a y-intercept. And how do I determine the y-intercept? I let x to be 0. Right. C, what is C and D are the x-intercept. I'm still talking to the f. Right. The graph of G cuts the y-axis at B. The graph of G cuts the y-axis at B. Right. They are saying now, determine the coordinates of A, B, and C. Right. What is A? A is a y-intercept. What is B? Y-intercept. For y-intercept, you let x to be 0. And thereafter, then you determine C. C is the x-intercept. You solve for x. For x-intercept, you let y to be 0. Then very important to look at B as well, coordinates of E and F. E and F, that's where the two graphs intersect. Remember, we said that on the linear, that when the two graphs cut each other, at that point where they touch, then they are equal. Then it means we're going to solve them simultaneously. Now we equate the two graphs. Which graphs? H is equals to F. So it means 4 minus x squared is equals to 3x squared. Then from there you solve them. That is the only one that I think we can do it. We've got h at x is equal to 3x squared. And we also have what? We also have f at x is equals to 4 minus x squared. So if you do this one quickly, then we equate the two. 4 minus x squared equals to 3x squared. Then if I move this on the other side, we have 4 is equals to 3x squared plus x squared, which is equals to 4x squared. 4 here divided by 4 divided by 4. Therefore, 1 is equals to x squared. Then from there, the square root on both sides, x is plus or minus 1. So once I've done that, then I can just get y. Therefore, y is equals to 3 times 1 squared is 3, or y is equals to 3 times negative 1, then it will be negative 3. It means now point E is negative 1 and negative 3. Point F is positive 1 as well as positive 3. When the two graphs intersect each other at that point, they are equal. You equate the two, then you solve for x. After getting the x, then you can get the value of y. Let's see the values of x for which f is increasing. That is a part that we need to look at. I'm going to leave it so that at least you can just look at it when I come and just complete the functions. Then I think we'll talk more about this one. Maximum, minimum, we spoke about the turning points of f and g and the equation of the axis of symmetry as well. Please, I need the answer, guys. When I come next time, then when I give you the feedback, please make sure that you are able to reflect back and then to say, we did this exercise, and then we are able to check if you are right and wrong. Guys, mathematics need you to practice. Grade 10s, very, very important. Make sure that you practice. Okay, right. Grade 12, that is the end of the session for today. Please make sure that you give yourself time. We look at the 3 questions, sketching, and then we determine the equation, then the interpretation. Please make sure that you give yourself time. Go through them again. Practice, practice, practice. Remember I said last time that you are now laying the foundation for the grade 11 as well as grade 12. Thank you very much.